lesson 4, 5-4 matching equations and graphs. Here we've got a graph, and Charlie Brown convinced Pigpen to take a bath. So we've got Pigpen down here, and it says the graph below shows the relationship of water when he gets into the tub. So, he is putting water into the tub, he goes for a bath, drains the tub, and gets out. Which parts of our graph show us all those things? So I'm going to label some points here. I call this point A, and this point B. This point C, this point D. Here's E, there's F, here's G, and there's H. Those are all different lines. We've got diagonals, horizontals. Okay. What's happening from A to B in the tub there? What's happening from A to B? You're filling it with water. Okay, so we're going to fill it here. Filling it with water. Okay, what happens right here from B to C? You shut the water off, right? So there, we shut the water off. Okay, what's happening on the next part? What's happening right here in D? C to D. Yeah, it's getting in the tub. Remember, whenever you get in the tub, the water raises, right? Because you're taking up space. So, from C to D right there, he gets in the tub. Alright. What's happening from D to E right there? He's bathing. He's got a rubber ducky and he's bathing things up. He's got his loofah. Okay? He's taking a bath right there. Alright. What's happening now from E to F?
Washing. You know what's getting out of the survey? He spent the same amount of time.
So, from E to F, he is doing what?
He is stop bathing and is getting out.
Good, he gets out of the tub. Okay, getting out of the tub. So what's happening right there? He's out of the tub and the water's just sitting there before he drains it. Okay? So that's the water level with all his toys before it's drained. Alright, what's going on right here? Draining the tub. Okay, that's draining the tub. So he pulls the stopper at the bottom and he drains the tub. Okay, now we're going to talk about 3 situations here. We've got 3 different graphs, and it says each student has a different plan to raise money for his or her sponsors. It says the graph shows the amount of money the sponsor owes related to how far that person walks in a walk for charity. Okay? So, we've got Sari, Monica, and Bruce. We have to match the equation to the graph. Okay? Which one do you think matches where? Who do you think matches where? What do you think's going on there? Sure, give it a try. It's the first equation. Okay, what makes you think that? Perfect, well said. It starts at +3. That's how you match graphs, everybody. I'm glad you picked up on that. So, where do you match the graph from? Where they start on the vertical y-axis. So we're going to match our graph. So what you should be doing is circling all their start points. Here's the start point. His start point is 3. His start point is 0. What's this start point? 5. Now, if they've all got different start points, we can match them very easily. If they have the same start point, we have to use a different strategy, and we'll come up to that in a moment. So, since this guy matches, he's got a +3, his start point, so that one's Monica. The +5 matches over here, so this is Bruce. And this guy's like saying +0 because there's no number after his variable. So it's like saying +0. That one matches Sari. Sari. Okay. Is that pretty clear so far? So the first step to match is check the start points. Okay? You've got a couple minutes to read through this. So the first thing we need to discover, first of all, is the main important thing we want is we only want a hidden 1 in front of our y variable. Hidden +1. If there's a negative sign there, we've got to divide it out. We always want a hidden 1 in front of the y equals. So that way it looks like y equals, and of course we've got that hidden 1 there, okay? That's what our goal is. So, moving through this was everything we discussed yesterday. So let's actually put this into practice. That was one way to do it, okay? So that was telling us, when we read that page, it was saying, okay, well, if I'm going to graph something, if this is my graph, and I've got an equation that says y equals 2x over 3 minus 4, it's showing me how to graph it. That's called slope y-intercept. Which one's called the y-intercept? Which one of those digits is the y-intercept? At the back.
I'll stretch it.
The negative 4. Good job. That's our y-intercept. Okay? That's called our y-intercept or the start point. Okay? Now, since it's called the y-intercept, we start on the y vertical line. So it's my start point. I'm going to start at negative 4 down here. Okay? And just like x bosses the y around, now this is going to tell that y what to do to his point. He's going to show him how to move it. This is called our slope. The bottom number always moves which direction, no matter what? To the right. Good. The bottom always moves right. Now, how do we know what the top number does then? It's going to go up or down, but how do we know which is which? Good. Positive's going to go up. If it was a negative, it would go down. And again, that's the number if it's sitting in front of x. Okay? It doesn't matter what the guy on the right does. That's where we start. It's the number in front of x that matters. It tells us where to move the point. Okay, so let's call our coefficient in front of x, remember? So now we're going to move 3 right, 2 up. 3 right, 2 up. That's our pattern. So we're going to go 3 right, 2 up. 3 right, 2 up. 3 right, and then I'm off my grid. And then you make points where you end up. And you join your points. Now I'm going to join them this time. How come? Because I don't have a situation telling me not to. I don't have a discrete situation. There's no problem-solving situation. It's generic, so I just draw my graph no matter what. Okay? The second way, the second way to match equations and graphs is this way. And this is what you've got to write down at the top of the one page. The second way is you take 2 points from your graph. Okay? 2 points from your graph. This is the top of page 2. You take 2 points from your graph and you substitute them into the xy coordinates. Okay, you substitute them into the xy coordinates of the actual graphing equation. Okay? Now, if it says if it satisfies or works, well, satisfies or works, what that means is, does the left side of the equation equal to the right side? And if it does, then yes, it matches. So, does the right side equal the left side? We're used to seeing this format, correct? We have to check a lot of our work that way to see if our equations have left side equaling the right side. So that's the strategy we use if we don't use the slope-intercept method. The slope-intercept method is the easier way, okay? But you still have to know how to substitute values. I'll give you a couple minutes to write that down. So we need to match these graphs. We're going to do it by strategy 1, then we're going to do it by strategy 2. Okay? Actually, we're going to use strategy 2 first. Strategy 2 says pick a point and see if it matches your graph. So I'm going to pick this point right here. Okay? That point is where? What would I call that point? It needs to have an x and y number. What would that x, y number be there? And if you're not sure, did x go left or right at all from 0? Remember, you're comparing from 0. Did x go left or right? No, x didn't go left or right, so that means it's 0. But then what did it do, though? It went up how far? 3. So its location is 0, 3. X didn't go anywhere, but y went up 3. So that's the point we're going to use. So what we're going to do now is for all the x's, we're going to put a 0, and all the y's, we're going to put a 3. Then we're going to see if the left side of the equations equal the right side of the equations. Only one of them will work because it's only going to match one graph. So let's give that a try. So I'm going to put 0 where the x is, and I'm going to put 3 where the y is. So 3 times 0 is? Plus 3 is? 3. So does the left side equal the right side?
Yeah.
Yes, it works on this one. Let's check this one. If I put a 0 where x is, and I put a 3 right here. Does the left side equal the right side?
Yes.
Yes. Oh darn. I have two equations that are matching. That means they have the same start points. Okay? What about this one? If I put a 0 for x and a 3 for y, 3 times 0 is 0. Subtracting 3 is negative 3. Does this left side equal the right side? No. So I know that these two equations, they have started at a plus 3. So which other one on here starts at plus 3? Which other graph? Graph C does. This guy also starts at plus 3. Okay? So between those two, we can't tell right now whether or not they're going to match the graph, which means we have to find a different point other than the start point. Let's try a different point. This one's got a point right here. That number will be going up 1 and, right 1 and up 6. So another point on this graph will be 1 and 6, correct? Does that make sense? When you're finding a location of a point on a line, you're going to find out how far right it went. This guy went 1 from 0, it went 1 right, and then went up 6. That's how I got to that point. Which means I went 1 right for my x, I put a 1. I went 6 up for y, that's my y number. That's how you put them in a coordinate point with brackets. Okay?
Why don't you start at your previous point, like the 3, and go up?
Oh, we can, but we don't start in terms of, we could say, yeah, 1 up and then 6 here. But if we started right here, it would only go 1 right and then 3 up.
Yeah.
That location is not 1, 3. Okay, to do a location on a map or a grid, we always have to start at 0, 0. Okay, to find the location. All right, so now I'm going to try the points 1 and 6. So I know that this graph, it could be either of these two. These two both start at 3. So I have to check both of these equations to see which one's going to have 1 and 6 that works. And I do the exact same thing. So let's try 1 and 6. If I put a 1 where x is, and a 6 where y is, let's see if the left side equals the right side. 3 times 1 is how big? 3. What's 3 plus 3? Oh, yay, we found one. Let's try it on the next one. We have this one right here. Oh, no, right here. So x is 1, y is 6. 1 plus 6 is how big? 7. Does 7 equal 3? No, it doesn't. So that's how I found this equation is going to match C. Does that make sense? So underneath him, I could put y equals 3x plus 3. And then right beside his equation up here, I'm going to say, okay, he matches C. Well, if he matched C, the only other one that starts at positive 3 is this guy. So who does that one match? Graph A. So this guy's going to match graph A. So we have x plus y equals 3. We only have one left over. Okay, we only have one left over. We're going to prove why it works. Okay, we're going to prove it. So this guy's an A. This guy will match B. So let's prove why. Let's pick a point. I'm going to pick this point right here. Now you can't pick points that are in between the grids. I couldn't pick one here that doesn't have a point right, because that doesn't put on one of my little square edges. It's got to be right at those intersection square edges. What I mean by that is it has to make like an intersection plus sign. Does that make sense? Okay? I can't go in between them. That would be like in thin air. You can't do that. So I need to find an actual point where they intersect, and that will be there. So this will be it, 2 and 3. Okay? So now we're going to check that. Okay. I'm going to take my 2 and put it in for x, and I'm going to put my 3 as y. So what's 2 times 3? 6. What's 6 subtract 3? 3. So does my left side equal my right side here? Yes, it does. So that's why this graph matches that equation. Okay, so you see how to do it that way? Is it much easier to do it the starting point way? Yes, it is. Okay, let's try another few examples here. You guys try those 3. Okay? Are those the ones we just did?
Yeah.
Those are the ones we just did. My goodness. Let's try this one. That's what we're trying. All right. What do you notice about them? Look at the equation itself. They're all starting with y equals, which is what we want. What do you notice about the actual grid? What's over there? Do they have a starting point? Well, they do, but it's not written. If it's not written, where is it? It's on the origin at 0. So all of those are like saying, okay, plus 0, plus 0, plus 0. Okay, which is why they all start at 0 right in the middle. Okay, well, we used 2 different strategies so far. We used the strategy where we substitute digits. We could still do that here, but it takes a while. Or we can use the slope-intercept method. Now, the intercept method, they have the same starting point. So if I have the same starting point, I have to use the slope now. So when you use the slope, what you do is you start in the middle, and then you do what the guy in front of x tells the y to do. So this guy right here has a hidden 1 in front, and I don't want to put any number into a fraction. You put a 1 on the bottom. So all of those need to be in fraction form. I'm going to put a 1 on the bottom. So you always need to be in a fraction. So you need to have the number in front of x in fraction form. And again, if you ask why, it's because it tells us how to move the dot. That's why. The bottom number will move right, and the top number is going to go up or down depending on if it's positive or negative. So it always has to be in a fraction. And if we don't see a bottom number, we put a magical little 1 underneath it. Okay? So on this one here, I've got 1. So what's that first graph here doing? What's it telling the y point to do? How's it going to move? 1 to the right, 1 up. So this one moves 1 right and 1 up. Okay? So now we start at the middle, and we're going to go, okay, 1 right, 1 up. Oh, which graph did I hit? I hit graph A, the pink one. Let's check its pattern. 1 right, 1 up, 1 right, 1 up. Do I hit the graph every time? Yes, I do. So graph A matches my first pattern, my first equation. Okay, you see how to do that? You guys match the last 2. Okay. All right. What is this second one doing? What is my second graph here doing? What is he telling x to, or the y to do? Good. 1 right, up 3. Perfect. So 1 right, up 3. Who do I hit? I hit B. Well, these are in order, my goodness. Didn't even realize that. That's obviously C, but let's check Y. So if I check this guy's graph, he's going to go 1 right, and then what? And then 4 which way? Down. Okay, so I'm going to go 1 right, 4 down. So 1 right, 4 down. Where do I end up? Graph C. And then we go 1 right again, and 4 more down. If I had a bigger grid, I'd keep doing that. Okay, is that a little bit clearer? Excellent. Let's go to some other lines. We have parallel lines now on the next page. So just taking a look at this one real quick. What did we notice? They all had the same what? The same start point. These guys all have the same start point. Okay, they all have the same start point. So let's look at our parallel lines on the next page, okay? So now we've got parallel lines. Well, what do you notice about their start points? Are their start points different? Yes. So start points are different, but what's the same this time? The 2x. What do we call the number in front of the x? That's called our what in front of x? It starts with an S. It's what you slide down. A slope. Okay? You slide down a slide, yes, but it's a slope you're sliding on. Okay? It's sloping. Now, remember, all a slope means is it's a diagonal line. Okay? So it's got, well, not always diagonal, but because you get on a flat slope. So, since they all have different starting points, it's easy. We can just match the starting points. And that's where we always start at the start points. So we don't have to worry about the slopes because we all know that every single graph here is going to go 1 right, 2 up, 1 right, 2 up, 1 right, 2 up. If I check all of them, 1 right, 2 up, 1 right, 2 up. This guy, 1 right, 2 up, 1 right, 2 up. Same here, 1 right, 2 up, 1 right, 2 up. So they have the same pattern. Perfect. But they all have different starting points. So now we're going to take a look at these starting points, and we're going to match them. Where's the plus 1? Where do I match plus 1? Good, B. B starts at plus 1 right there, okay? So, this guy matches B. Okay? Where am I going to match the next one? Where does he start? He starts at -8. And -8's down there, letter C. Over here we start at +5. 1 left only. It's got to be A. Okay, so what do they have in common then? Well, we said they all have the same slope. Okay, they all have the same slope, which means their dot moves the same. So their point moves same. 2 up, 1 right. Okay, so the point all moves the same. What is different? Their start points. Now, what's the fancy name for start points? It's the constant, yeah, it's our constant. That's not a fancy name, though. I heard somebody say it. Out loud. The y-intercept. The word intercept is like an intersect, where the graph intersects or touches that y line. That's why it's called y-intercept. Okay? So that's the part that's different. Let's take a look at what's coming next. Now we've got some more lines coming. It says when the graph is written in this form, it's just reminding us m is our slope, b is our y-intercept. Okay? So now we're going to take a look at a couple different lines down here. We want to find out which line does each of those represent. So try and match the equation to the line. Okay, try and match the equation to the line and see which one it matches. Give you a minute to do that. Okay, let's take a look. Our very first one has a start point of +2. Where do I find the +2? Which graph do I find a +2 with a line touching it? Which color line? The red one starts at +2. Remember, I'm not looking for the 2 down here. I'm not looking for the x2. I'm looking for where it starts on the y. Okay, I'm looking for where it starts on y. All right, so that means that this equation has to match the red line. Okay? Check your work and get that right. Good. If you didn't, you see why you didn't get it right. Kind of? Nope. Yeah? All right? Okay. All right. Let's check the next one. This guy's going to start where? +1. Which graph starts at +1? The blue one. So this guy here matches our blue line. Now remember, if there was multiple graphs starting at the same place, then how do I match them? I have to move to the next number. Which number do I look at then? Yeah, I look at your 3x, good. You look at your slope, and you check and see what's he doing. Well, we check. This guy's going 1 right, 3 down. Perfect. What's this guy doing? Well, he's going 1 right, 2 down. 1 right, 2 down. Is that correct? No. So they have different slopes. All right. Next one. You guys try and match those two up. But what do you notice about the equation? Is the variable y isolated? No. If the variable y is not isolated, we need to isolate the variable. So how are we going to isolate that variable? Divide? Well, we got to use opposite operations. We're going to use inverse operations. Remember, we need to make a zero pair because we need to take the other guy to the other side of the equation. We want to take him off the other side of the equal sign. So if I want y by himself, this x here has to take off and go through the 2. So how do I make that x go bye-bye and go to the other side? I subtract by 1x. Very well said. I subtract 1x here, which means I'm going to subtract 1x over here. Okay? All you're doing is making a zero pair. You're putting it to the other side. Okay? So then I'm going to rewrite my equation. I'm going to get y equals 2 subtract 1x. There's my new equation. So, does that equation now start with y equals? Yes, it does. So can I graph it now? Yes, I can. All right, so let's try and graph that one. So where does he start? Does he start at -1 or does he start at 2? How did you know 2? It's the constant. It doesn't have a variable. The 1 has the variable, so that's not where we start. Remember, usually the number where we start at is the end of the equation. Sometimes it's not, though. Sometimes they trade places, and that's okay. You just have to remember it's the number without the variable. It's the constant. So, right now, this guy, the 2, is telling us where to start. So if I go to 2, which line do I end up at? Line B. So this one's going to be line B. Since I only have 2 lines and 2 equations, this guy's obviously line A. But let's figure it out and how it works. Which means all I want to do is I want to take my x to the other side. I need to isolate the y. So how do I take that negative 3x? So 3 red sticks on that side. How do I get rid of them? Add 3x's. Perfect. So you're going to add 3x's. So now I can rewrite it again. I get y equals my -2, and then my plus 3x comes beside them. Now, could you rewrite that? Yes, you could. You could flip-flop these guys' places. As long as the 2 stays negative, because that tells us what color he is, red or blue, green. And the 3 has to stay positive, because that again tells us red or green. And it also tells us whether it goes up or down. So, we could rewrite it with x first, 3x, and put our -2 at the end. And that's okay. Both of those are correct. And you'll get the same answer on a graph. So if I look at my graph now, this guy says I start at what number? -2, so I'm going to start down here. Then what does it say my dot has to do? How do I move that dot?
1 right.
1 right,
Yeah.
3 up. So if I go 1 right, 3 up, guess where I end up? Okay, I'm still on that A line. Okay? Good to go so far? Okay. Well, there's sometimes we have situations where we have to substitute x and y coordinates in there. Sometimes it's going to say, is this point on that line? Well, if we don't have a graph, sometimes we can't tell. So we have to use a different strategy. And the strategy we use is by putting x and y into the equation. And then we simplify it and we see if the left side is equal to the right side. We've been doing this for a long time. So it's basically that check that we did in Unit 4. When we checked our work, we substituted our x values in. That's all we're doing here. Same stuff. So, here's the example at the bottom we'll do together. Okay. So we just were discussing substitution. How do you know if the point is on a line? And they don't give you the graph, so you can't tell. Nothing is drawn for you. Well, we can do it manually. There's a way to do it manually. So we follow all the steps it says here. And what it's basically telling us to do is to take each of the x and y numbers. We do them separately. There's my x, there's my y. And I put them where x and y are in the equation. And then I see if my left side is equal to my right side. So I make myself a T-chart for left side, right side. Left side, right side. I've got my y here, my 3x plus 2. Now I put my numbers in for x and y. Okay? First numbers are 5 and 4. So 4 is the y. 5 is the x. So I want my left side of the equation equals 4. I want all of this right side to equal 4. Well, let's take a look at what it gives us. If I take 3 times 5, how big do I get? 15. If I add 2 more, what do I get? 17. So is my left side equal to my right side here? No. So left side is not equal to the right side. So this point is not on the line. So no, it's not. Okay, it's not on the line. And then we're going to do the exact same thing and switch the numbers. Okay? We're going to do the exact same thing. We're going to use the second set of numbers. We're going to use the 3 and the 11. The other x and the other y. We're checking to see if it's on the line or not. Okay. I'm going to erase those. I'll give you a moment to look at mine in a moment, okay? So let's put those other numbers in. y now is 11, and x is 3. Well, let's solve my right-hand side. If I take 3 times 3, how big do I get? 9. What's 9 plus 2? 11. So in this case, my left side does equal my right side. So that means, yes, this point is on that line. Okay? That's how we can tell. With this next equation, this one's talking to us, well, how do we know if an equation matches points or values for variables? Well, there's ways we do again. All we do, the exact same thing we just did. We put x and y where the x and y go, and we solve left side, right side, do they equal? If so, they match. Okay? We're going to do exactly that with this example. If we take a look at this example, it says a is my 15 and m is 5. I have to check each one of these because it's a multiple choice. Which one does it match? So I'm going to put a 15 where a is. That's my left side of my equation. Left side, right side over here. And then it tells me that m is 5. So 3 times divided by 5 plus 10. So I put my 5 in for m. And now I solve both sides. Okay, let's check our bed mass now. If I take 15 plus 5, I'm going to get 20 over here. 5 times 3 is my 15 on this side, plusing 10, which gives me 25. Does the left side equal the right side?
No.
No, the left side does not equal the right side. So I know that this equation doesn't match those 2 points it gave me. Okay? Then I take the next equation and I do the exact same thing. I want you guys to take equations 2, 3, 4, 5, do the exact same thing I did. Put the 5 where the m sits and put the 15 where the a sits. And try and see if the left side equals the right side. I'll give you a couple minutes to do it, and then I'll put the answers up there. Check equations 2 and 3. Left side is 15 because it's got the a sitting there. Then I put my 3 times my m plus my 10, subtract my m. That's everything here with all the numbers put in. Now you do bed mass. 15 plus 10 minus 5. 25 minus 5 is 20. Does 15 equal 20? No, it does not. Okay, 15 doesn't equal 20. So it can't be equation 2. Then we look at equation 3. We do the exact same thing for equation 3. On the right-hand side, I put the 5 where m belongs. I get 10 subtract 5, which is 5. Does 15 equal 5? Heck no. So 15 does not equal 5. So it's also not equation 3. So it's got to be equation 4 or 5. And we do the exact same thing to equation 4 and 5. Here's equations 4 and 5. Equation 4 has the a, 15. Then it says subtract 2 times the m. And my m number is 5. On the right-hand side, it has a negative 5. So I do bed mass. 15 subtract 10. 15 subtract 10 is how big? 5. Does 5 equal negative 5? No, they're not equal. So by process of elimination, I know 5 is the answer, but let's prove why it is. So we've got 15 on the left for A. Got my A on the left. So now I'm going to multiply this guy in the brackets. So I've got 2m plus 4 equal, or plus 1. If you didn't want to do that, you could just put m where it is. M is 5. 5 plus 2 is 7. 7 times 2 is 15. We'll get this, or 14. We'll get the exact same thing as we do the other way. So I'm going to have 2 times 5 plus 4, plusing 1. That's going to give me 10 plus 4 plus 1, which is 15. So 15 equals 15. So my left side equals my right side. This is the correct solution. Okay? My check mark went through my equal sign. It shouldn't have. Correct solution. There we go. Okay, when we match equations, the first thing we want to do is we want to see what digits are going to touch. So if I'm matching the D or the A one, A is going to touch that line. What number does A touch the line on? 3. Now does he touch it on an X number or a Y number? a y number. So we need to find y equals 3. Good. So if I find y equals 3,
I was looking at the phone.
I'm going to find
That's probably right.
y equals 3, equation 4. Okay? Or you can just write y equals 3 is fine. Okay, it's equation 4 that it is.
Yeah, it's right.
Yeah, E4 fine for equation 4, sure. Then we take a look. Where does the B1 cross at? What number does he cross at? -8. So, is it an X number or a Y number he touches? It's a Y number, so we need Y equals -8. Well, that would be right there. Equation 2. Okay, you guys try the 2 vertical ones. What should they start with? They should start with X equals. So now we can cross off the other Y ones. There's only one other Y one. I didn't do that very well, did I? Should have put a few more on there. Okay. Where does this one cross? D. +4. So what am I going to write for that one? X equals 4. So equation 6 is D. Where does equation C touch?
-1.
-1. So what should I say for that one? Y equals -1 or X equals -1? X equals -1. Equation 8.
It'd be odd. Like,
Oh, weird. I went 2, 4, 6, 8. They're all even numbers. I didn't even plan that. Okay. This concludes matching equations and graphs.